So because of all my fans we enter one chance as a result of this question, I don't come back to come explain this question for now. Because you know, say I dey always promise. Any promise wey I make here for any of my fans, I dey always come back. Because you know, say this question you go see am for your Jamb UTME 2026. Flotation dey syllabus, abi na movement, nano dey syllabus, abi na conservation of energy. E dey syllabus, okay? Beam balance, na be the first part for your Jamb UTME syllabus. And Jamb UTME dey always repeat things from beam balance, top palm balance, lever balance, spring balance, all those balances, all the calipers, and the micrometer, screw gauge, meter rule. They always repeat questions for their types of error. So this one an opportunity for you to earn that free mark for your Jamb UTME 2026, because you are definitely going to see questions from this topic. So let's look at the question. The question reads, the working of the beam balance is based on what principle? Option A, moments. Option B, flotation. Option C, conservation of energy. Option D, equivalence. Before you answer this question, as a smart Jamb UTME science student, you have to understand what a beam balance is. You know what be beam balance? Beam balance one resemble that thing where they dey cut off law, okay? Where they be like this, where you go put something here, this weight, if this weight big past the one where they here, you go push and counter. If this weight big past the one where they here, you go push and counter. And so it be na beam balance. Which principle that thing they work for? Remember, say there is a to and fro movement like this. There's a to and fro movement for the way beam balance they work. It's a to and fro principle. So as you don't understand, saying a to and fro principle, now beam balance they work to and fro like this. If you pull weight for here, if the weight where they here pass the one where they here, it will bring this one down, this one will go up. So now these are the compare two weights, or you go use the weights where they take calibrator to take know the weight of the object where you put. You come minus am, can't do the calibration. You can't get the mass of the object where you put. You know that beam balance is used to measure mass. Okay, it's used in mass measurement and not used for weight. And what is mass? Hope you can define mass. Mass is the amount of matter contained in a substance. So, or in a substance or in a body. So we don't already know the mechanism where beam balance. Always think, conceive ideas when you see question. Even though say you no fair know the way the thing fair they work, but just think and beam balance. What be beam balance safe? How beam balance they work? Just think. And I know say many of us for here we never even see beam balance before for our life. Now so schools be, especially for Nigeria. Now so school. Even me, before I see beam balance, I don't almost graduate come up for school. Now small thing remember I write my WAEC before I see beam balance that day. Why I can't see beam balance? Where we they do practical. Now I can't see beam balance. I can't know it be. I can't know how it really work. But even at that, we don't already know say there is a to and fro movement. So what you have to do now, among these options where they here, which of them involve to and fro movements? Find the option where involve to and fro movement. We'll look for them together. I know say the smart ones, the smart UTME candidates, the smart candidates don't find the option where they here, where be say they work under the principle of to and fro movement, oscillation. But we start from option D. Option D now equivalence. Could the equivalence be the answer? That's obviously wrong. Equivalence is wrong. This one no join. Equivalence no join. So more come on that one. Then the next one we'll get here now conservation of energy. Conservation of energy, they work under to and fro movement or oscillation. That's obviously a wrong answer. So this one no join. So the third and the fourth option don't go. We are left with only two options, flotation and moments. Flotation. Flotation, they work under principle of to and fro movement. Like this, to and fro, oscillation, or like this. If they work like that, flotation, to and fro. Yes, to and fro movements get some form of oscillation inside. Because if an object they flow, if they flow like this, there's a to and fro movement, you understand, for flotation. Okay. But the beam balance, you know say flotation now for inside water and fluid. But beam balance no get any relation with water or fluid. So now make we no fit pick this answer. So okay, so we'll look the final option we will get. The option we'll get final na moment. What is moment? The turning effect. Moment can be defined as the turning effect of force about a point. The turning effect of force about a point. The middle of the beam, here, around here, that's where you have the fulcrum, okay? You have the fulcrum of the beam, okay? Here is the point. Here is the point, the imaginary point of the beam. Here, so is the point. Then here, okay? The turning effect, that's where you have the turning effect. So the answer is moments, the first option. So the working of the beam balance, which is used in measuring mass, works under the principle of moments. Congratulations on earning this free mark. Please appreciate me in the comment section. Don't be say when I don't die, you can't say these guys are be teach. I don't want to be idolized. Okay, whatever prop, whatever flower you are giving me now, give me my flower right here now. Make a see am. Drop them for the comment section. Share this video to your friends. As you see them now, I don't help you secure free marks for your Jamb UTME 2026. Share them to your friends. Make them still secure their own free marks. I beg. Now God that they beg you. Jamb 2026 candidate.